Welcome to Organic Chemistry. This is a review of how to name different kinds of organic compounds. Let's start off with some of the prefixes you'll often see. First off, we have methane. We have meth, which stands for 1. Eth, prop, bute, pent, hex, hept, oct, non, and dec. So eth is 2, prop 3, bute 4, 5, 6, 7, 8, 9, 10. And then we also, so these are our prefixes. We also have suffixes depending on whether the hydrocarbon is an alkane, alkene, or alkyne. So if it's an alkane, it ends in ane. Alkenes will end in ene. Alkynes will end in ine. And so here are suffixes. One way to remember them is alkane goes with ane, alkene goes with ene, and alkyne goes with ine. So as an example of some of these, if we wanted to combine them, we could have, when we have what we call methane, so this is the first part and the suffix, these prefixes here, these prefixes stand for the number of carbons that you have. So for methane, we only have 1 carbon. So for methane, we only have 1 carbon, like so. Also keep in mind that each carbon needs to have 4 bonds, so we attach the rest as hydrogens. We can also write this as the chemical formula CH4. And now let's do an alkene. An alkene has double bonds, so let's say we do propene. Propene. Prop is our prefix, ene is our suffix. So we know that the chemical formula is C3, and we're going to look at the number of H's, but let's draw that first. So we have our double bond, and we have another carbon. And in this case, we don't have a number at the beginning because no matter which way we have it, the double bond will always be at carbon number 1. So if we attach the number of hydrogens that we need, it looks something like this. And actually, we shouldn't draw the carbon next to it. Due to the double bond, it's actually going to be slanted. So we have something that looks like this. So with each carbon has 4 bonds, and each hydrogen only has 1 bond. So if we count out how many hydrogens we have 6. So C3H6. Now let's do an alkyne. How about butane? And we'll do 2-butane. So in this case, the 2 denotes where the triple bond is. So we have our triple bond, and we have 2 more carbons, and the 2 carbons in the middle, the ones involved in the triple bond, already have 4 bonds, so we only have 3 hydrogens on each end of this molecule. So bute is our prefix and ine is our suffix. So we find that this chemical formula is C4, since we have 4 carbons, and H6, because we have 6 hydrogens. Another thing to keep in mind when we're dealing with alkenes specifically, so this is for alkenes, we also have the option of having cis as a prefix or trans as a prefix. And in this case, cis means that the two other parts the two other parts of the two other carbon groups that are connected to the double bond are on the same side. So this is same side. And trans means they are on opposite sides. So these are on opposite sides. So it might be easier if we write R in terms of, so R in this case is just any hydrocarbon or any succession of carbons, basically. So if we have an example of cis, so this is cis, and this is trans, we have our double bond here, and we have R's, and these are H's. And for trans, we have two C's, but here our R's are on different sides of the double bond, so we can't simply flip it and expect that the R's will be on the same side. So here what we're looking at is sort of when we draw this dotted line through where the double bond is, whether the two R groups are on the same side or on both sides. They're on the same side or on either side of the line. And sometimes, such as in the case of propene, we can't say whether it's cis or trans, so it's actually neither. Because what we find is since we only have one R group here, it doesn't really matter, because any way we flip it, we'll always have only one carbon group on one side of the line if we draw it like so.